Here's a very typical conic section problem. Rather than give you the equation of a conic section and then ask you to graph it or give a lot of information about it, like the vertices and all those sorts of things, the foci and whatnot, instead they'll give you the information about the conic section, and then you'll have to backtrack and figure out the equation of the conic section. And so you can do this with ellipses or hyperbolas or any of the conic sections, but for this particular example we're going to do it with hyperbolas. So here's what they give you, and even these problems can vary. For our problem, they gave us the vertices and a point on the hyperbola, but you could be given the foci, you could be given the center, you could be given the asymptotes of the hyperbola, you could be given anything, but just for this particular example, we have the vertices and we also have a point on the hyperbola. So let's plot the known information, and then we'll see if we can kind of backtrack from there. All right, so let's make us up a graph. And so we'll kind of start with the graph, and then we'll see if we can write the equation based off of the graph here. All right, so the first thing we were told was something about its vertices. The vertices were at 2, -1 and 2, 5. Let me plot those real quick. So let's see here, 1, 2, -1, and 1, 2, 1, 2, 3, 4, 5. And these two guys are the vertices. So right off the bat, can we already tell if this opens up and down or left and right? It's pretty clear to me that this guy's going to open up and down. Now from here, I think we can easily see the center. The center would be exactly halfway between the two vertices. So let's see, what would be the halfway point here for these two guys? The center would be at an x coordinate of 2, because notice these didn't change, and then the y coordinate would be 2, because that's halfway between -1 and 5. You add them up and divide by 2. -1 and 5 make 4. 4 divided by 2 is 2. Look at our graph just to double check it. 2, 2. Yep, that looks like the center. So that's pretty good. But now I also need to know how steep to make this graph. Is this a very wide graph, or is this a very narrow type of hyperbola? And I think that's why they give us the little piece of information about the extra point on the hyperbola. It goes through 0, 8. So let's go here, 0, 1, 2, 3, 4, 5. I don't know if my graph will go that high. I'll try 6, 7, 8. Okay, so this point here is also on the hyperbola. So it kind of gives you a gauge of how narrow this graph is gonna be. So let's see if we can use that to our advantage. We'll start building the equation the best we can. Because I know that this opens up and down, I know it's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. I know the h and the k already. The h and the k is 2, 2. So we'd have y minus 2 squared over a squared. Now what's a? Well, a is the distance from the center to the vertex, and that's 3 units, as you can tell, from 2 to 5 or from -1 to 2. They're both 3. So no, this will be over 9, and then minus x minus 2 squared over b squared equals 1. So the only thing I don't really know right off the bat, if I knew this, I would be done and we'd be finished with the problem, is I don't know the b. The b, I don't immediately see anything that will help with that. But what I do have, don't forget, is this extra point 0, 8 that I haven't used yet. And what this means is that when x is 0, when the x is 0, the y will be 8. It's pretty straightforward. So let's see if we can use that to our advantage. Let's let x be 0 and let's let y be 8. All right, let's see what that yields. So if y is 8, 8 minus 2 is 6. 6 squared is 36 over 9 minus let's see, the x coordinate was 0 when the y was 8. So 0 minus 2 is negative 2. Negative 2 squared is 4. 4 over b squared equals 1. And this gives us an equation that we can solve for b. So let's do that. So let's see, we'll subtract 36 over 9 from both sides. I'll do this up here in the corner. So we get negative 4 over b squared equals, let's see, 9 over 9, that's 1. 9 over 9 minus 36 over 9 will leave us with 27 over 9. Actually negative, sorry about that, negative. You can divide both sides by negative 4. We get 1 over b squared equals 27 over 36. That's 9 times 4. And then we could take the reciprocal of both of those. So b squared equals 36 over 27. And so b would equal the square root of 36 over 27, which would be 6 over the square root of 27, and the square root of 27 would be 3 root 3, because that's 9 times 3. The square root of 9 is 3. And so this is our b value. So we would want to put b squared. Now, actually, I didn't even need to do the last step. I should have noticed this from earlier. I really just need the b squared down here, which is actually already provided, 36 over 27. So I'll just go ahead and erase this right here, this b squared. And we can either put a 36 divided by 27, but since this is a fraction over a fraction, you have a fraction in the denominator, let's instead multiply by the reciprocal. So you see, we can build the equation of a hyperbola based off of known information such as vertices or points on the hyperbola or the asymptotes or the center or what have you. You basically just start with your generic model and then just start piecing things together based off of what you're provided.